Well, I could say this. We've tested enough of the zip and the force field systems and all systems to understand that the failure modes are the same. So it really depends on the builder and how it's constructed. If you don't build correctly and you have leaks, I don't care what you put up there, it could be zip or force field or Housewrap, you're going to have trouble.
We're at Watson Springs with my friend Landus Bennet. Hello, Landus.
Hello, Corbett.
We are going to do a breakdown because I get this question a lot. Which sheathing system, or WRB, or should I use Housewrap, or zip, or ForceField, or what? Is this tape better than that tape? This guy actually knows. So we're going to go through the whole list of what he's actually been researching. He likes to call it ideated. But Landus was one of the people who invented the very idea of an integrated WRB. Is that right?
That's correct.
Great.
Yep.
So he worked at Huber, where they invented zip, and he was there then. That was part of his idea. Then he went to work with Georgia Pacific and helped invent this as well, right?
Right.
Why are there bloody holes in these panels? Landus has been testing these, and that's a different video than I'm looking on screen right now, so tune in for that one. Let's start with this, because this was first on the scene.
Okay.
What are the pros of this, and what are the failure modes of this?
Okay, so the pros of this is that you, when you're building a house, you install this and you take the seams, you don't have to install Housewrap. So as a step in building, it could save you a little bit of money because it's much faster to do. So that's a good pro of it. Another good pro that we've come to learn over time is it's a great air barrier. And air barriers are a good thing when you build houses.
Now, you did not intend for this to be the air barrier original, like that was not.
Well, we started off on the roof, and so we were thinking water more than anything, and that was kind of the main concentration was how does it do with water. When we started working on the wall, we learned pretty fast that probably wall's more important than the roof with this, and that it does make a great air barrier.
Okay.
And so, yeah.
So I'm going to do some like interjecting here because I've known Landus for a long time, and I've heard a lot of different stories from him and several other people who were there at the invention of both of these things. Because you started with the roof here, it was for the roof, then they started selling it for walls too. And what I remember Landus telling me is that this is overkill for walls, which is why you helped develop this one, because it's like you don't need to have something that is roof, quality that's going to be walked on and all this stuff. For the walls, you can do something that's a little lighter, which this tape, some people are a little suspicious of it because it seems like it's packing tape.
Right.
And Landus, you said,
what's wrong with packing tape?
Right. What is wrong with packing tape? So would packing tape technically work as
on a wall? I think that it would, even though these tapes are better than packing tape.
Yeah,
packing tape would work.
Absolutely.
The primary difference that we see between the two, or that we know between the two, is basically the way that they're made. Zip's made in a primary process, and ForceField's made in a secondary process. In other words, the panel is made first, and then the overlay is put on. Where with zip, it's put on during the process of making the OSB. With that said, there's some differences in permeability between the two. Now, whether that's a bad thing or not, it still remains to be seen. But if you test as a system, that is with the panel and the overlay, the zip's going to be in a semi-impermeable range, and ForceField's going to be in a semi-permeable range.
Gotcha.
But, I want to clarify, when I say you don't need this in wall, it's the durability. And this is a very durable overlay. It is not coming off. That's the kind of durability I'm saying in a wall. You're not getting walked on and all. You don't need that on a roof where somebody's up there walking on it. You got the roofers on it, this, that, and the other. You may even have a mason
falling.
chimney,
sure.
God forbid nowadays, but you might, something masonry coming through. All that's got to be done. So you need a little bit more durability. Walls, once it goes up, then that's fine, which would lend better on something like this.
So this one is cheaper than this one. It was designed to be that way, in fact, right?
Yes.
Less expensive. Okay. Not cheaper. Not cheap like I've used this on project. I've used this on project. We use this on our own house.
Yeah.
It's not less good. It's different. And I think that's the important thing that I want to make sure that our audience hears.
Yeah, it is. And as we said, when it comes to failure modes of this, they're really the same. And as you can see right here, overdriven nails. That's kind of a failure mode right there. That if you're especially in the reservoir type cladding, brick or stucco or something like that, that could be a problem.
This one, though, just to be clear, is not approved for roofs. Is that right?
It is now.
Is it really?
Yeah.
Oh, thank goodness. So shipping tape, and the idea here with, the fact that this was 4 walls, and I'm interested to hear about the roof thing, but like you could just tear this with your hands. You're not tearing that with your hands?
No, I'm just
right?
taking the
This
release
is-
liner
yeah.
off. Yeah, this
So-
will not tear by hand. Yeah, this is the zip flashing tape. Their seam tape doesn't have the release liner on it. The flashing tape does. But they're very similar in thickness and of course the chemistry's the same.
Yeah, right. And they're all very sticky. This, just to remind everybody, this is like shipping tape, but it's made to withstand UV. Is that right?
Yep,
Okay.
yep.
It's built on the chemistry. We achieved 0.4 ACH50 with this. I was even surprised about that. I thought, wow, if we could hit 1 ACH50, that'd be great. Just for anybody who's watching this who's not a super nerd this far into the video, you're a super nerd now that you made it here. But blower door tightness is what we're talking about. So passive house, 0.6, we beat that by 50% with this stuff. A lot of people didn't think that was possible. We wanted to tell the story of why, like that it's a system, not a product, right? So it's
Right.
how you do it.
Or it is, and when you're taping the seams, now this tape, and I would say again, when you're using the integrated system, use the tape that the manufacturer supplies because it's engineered for that. This tape would probably not work well on this panel because of the texture on the panel. So you got a smooth surface here, and you got a textured surface here. So this tape is a little bit more aggressive, has a little bit more adhesive. The adhesives are the same, it just has more of it so that it could get in up and down in these little valleys and flow in there and prevent water from getting through those valleys.
Now, the reason that we have these at all, and by the way, there's a third one called Georgia Pacific is ForceField, Louisiana Pacific makes Weather Logic, is that right?
Right, Weather Logic.
And it would be kind of like, which one, is it?
Yeah, it's almost identical to Zip.
Okay.
In that it's made in a primary process as well. And the tape is very similar.
Okay.
I mean, I think everybody's going to pretty much go to the acrylic tapes now because of their temperature range and the ability to make a tape thinner and maintain its durability.
And just to remind everybody, by the way, thinner tape might be better at shedding water because it doesn't have a little edge that the water can sit on.
Right.
Now, there's a way to make your own WRB on site if you want to with a fully adhered membrane or on the outside. I like to recommend Ad Hero from Proclima for that. There's paint on stuff. Like to me, they make this stuff in a factory. It's going to be faster and better. So you can do that. But the reason that we have this at all and that Landus and a few of his colleagues came up with this whole idea is because this was what we were working with.
Right.
What is the downside of this?
Well, one, when this came out, it came out as an air barrier. And if you look at it and you put it on a house, the bottom of it is loose,
And
just like that. And so
no
air
matter
gets
what
up in there.
brand you're talking about, like Tyvek, Typar, or any of the other,
Oh,
often
it'll be the
you'll
same.
have to void the warranty if you seal this bottom seam. Is that right? Because they want any condensation that's back there to be able to drain out.
It's got to drain the water that gets behind it,
Out in the wettest place in the United States, out in Washington, Housewrap, the house looked like a pregnant house because it was holding so much water. It was a belly.
It had a moat.
It had a belly full of water. You know, we've been using Housewrap now for, it's 80% of the market. It's my opinion that's going away, that we're going to tape systems, and that's what I promote. More than anything here at Washington Springs is that is the promotion of a tape system and how you can use that in the best way to practice tape systems.
Why is it better?
Number one reason is air infiltration. You will not get down to a 3 air change per hour with Housewrap unless you make that Housewrap trap water. That's the only way you're going to do that. So having a tape system with no trapping water overlay on it so that you can shed that water away is much better. And the tape's going to give you much, much better air infiltration. Now, if you want good air infiltration with Housewrap, you can go get this expensive $100 a roll Sika tape that takes primer and put on there. But think about it. You know, you're taping over OSB, which is full of voids and stuff. I don't care how expensive the tape is in the primer. I don't think that they perform as well when it comes to water or even air as an overlay system. 90% of what makes this work is you got a good surface for tape to bond to. And you've covered voids. You got a great system for it to tape to. That'll give you a good air barrier, and it'll shed your water away. The fluid applieds coming out, I think they do a good job. Thinking about using fluid applied with house wrap right now kind of scares me a little bit. What somebody may do with that and what it would do to trap water.
So Tyvek, most people are familiar with this stuff. You go to Home Depot or Lowe's and they're like, oh, just buy this instead.
Yeah, there's different types of house wraps, and this is a particular good one that you can see it's more solid. It's got this fiber behind it that helps give it strength. Tyvek again is a good solid surface, and then there's these woven, and you can look at it and you can see that it's just little strands that are woven tightly together. These solid ones will do better about keeping water from moving through, where the woven ones don't do a very good job of it at all.
And is Tyvek permeable?
Tyvek is permeable. I think it's about 25 to 50 perms.
Great, and the ones that are just made of woven plastic bags are probably like a lot less permeable, number one.
Well,
potentially.
Being that they're woven, they're allowing vapor in and out. They're high permeability too.
Oh, interesting. But they're also not airtight.
They're not airtight, and they allow liquid water to migrate through.
Right. So they don't stop really anything at that point. Okay.
No.
So it's just a gesture at that point.
Yeah. It's a gesture. Yeah. And you know, it's what a lot of builders use, especially production builders. You know, they're going to use the cheaper house wrap. It's what code allows. There's no code man out there says, oh, you use the woven, you're in trouble. You know, and think about it. I mean, we've built without house wrap for years before house wrap. I even built without house wrap.
Can you kind of explain the journey?
I mean, when I started in the building in the 70s, it was fiberboard that we were putting up as sheathing. And to get structure, you would have to cut a 1x4 into the studs on the inside of the house, run it diagonal. And then they came out with this little metal strip, so you didn't have to cut the studs anymore, and you could just take one saw, just a saw kerf, and you could put that little metal strip in there, and that would give you the strength. But then they came out with plywood for construction. It was all this nice smelling Doug fir, beautiful plywood. And they said instead of having to do all that cutting in the corners and stuff like that on the inside, you could put the plywood on the corner instead of that. And so we do that, and then you put the fiberboard, which then went to a insulation board, Celotex or R-Max. And so it was still plywood on the corners. And then the R-Max, and then OSB started coming around, and it was cheaper than the plywood, but still more expensive than the insulation board. So you replace the plywood with the OSB, but still put insulation board everywhere. Back then we weren't putting no house wrap, nothing that was going on. You just put your siding right on top of that. As OSB prices came down and insulation board prices went up, people just started putting OSB all around the house. And for a framer and a builder, you're like, oh, that makes a strong house. That's good and strong, you know, but you think about it, we were doing continuous insulation in the early 80s before continuous insulation became a thing like it is today. And then we switched to plywood, but it was all cost driven. Everything was cost driven in those changes.
First cost.
Yeah.
Yeah.
There was nothing that I could think of that really performed, even though you'd say putting OSB over the whole house, it makes a stronger house. It was, to our opinion, a better construction because we were doing that, but it was still done because the OSB was cheaper than the insulation board.
Now, OSB can be stronger than plywood. This is something that I've heard from people in your industry. Can you explain what that means and if that's true?
It can be because plywood is directional. And so if you were to put plywood on this wall, you would have to put it in this direction. So the 8-foot direction would have to go along the wall or perpendicular to the studs. If you stood it up, then you have a weak parallel direction. So plywood is very strong in the long direction and very weak across the 4-foot direction. OSB, on the other hand, is closer in its properties and its structural properties in either direction. It can be made to be almost the same in either direction. But even today, as it's made, you're able to put the OSB either way you want to put it up.
So part of the reason that I wanted to have this discussion with Landus is because I have clients who are in analysis paralysis mode, and they say, I want to have WRB sheathing, and then I want to put house wrap on top of it, and then I'm going to have spray foam applied from the backside, even though it's already got its own R, you know, like the zip R with the foam on it. And then I want to have aero barrier come in at the end. And it's just like, that is way too many products that you're trying to assemble into a system. It's got redundancy that's it's like not contributing at that point.
You want one vapor barrier in your wall.
And when you say vapor barrier that way, you're talking about something that controls vapor, not that blocks vapor, right? We're not talking about sheet plastic.
Well, you know, Tyvek, you know, you put that and you've got a vapor barrier with that on the outside, then you probably shouldn't put one on the inside. You definitely don't want like a plastic type material, the vapor barrier that they do up north on the inside and on the outside. You're just trapping moisture in there.
And just to be clear, having come from Chicago, every summer we'd get calls, and Chicago's a northern city, but any place where you've got 2 seasons, heating and cooling season, the plastic, like that, the vapor barrier, when we're talking about something that literally is impermeable, is in the wrong place half the time. So just don't do that. A vapor control layer like this, like the 25 perm building paper.
Yeah.
That's what we're kind of talking about when Landus says vapor barrier.
Maybe a good way to put it is less is more, you know, and so if you eliminate that layer and you're down to just this and tape, you've sort of eliminated a layer out of it. And, you know, why put spray foam and more stuff like that? You're just taking away drying potential. So this is wood. It will get wet, it'll rot, it'll attract bugs when it does, so you want to keep it dry. If it does get wet, you want to allow it to dry out. So stuffing a bunch of stuff around in your walls is probably not a good thing.
So just make sure that whoever it is that's building your home, and if that's you, good job, we're with you. But do one thing well, and then use redundancies that make sense. And if you don't know what those redundancies are, subscribe to this channel. Make sure that you're watching Matt Reisinger's channel, obviously. But like, you know, trying to make affordable decisions that are going to keep you out of the analysis paralysis mode, I think is important.
Right. I think the most important thing if you're choosing an integrated system is you're going to get a tight house if it's installed correctly, probably below 3 air changes per hour. So you need to think about bringing in fresh air with ventilation and maybe some dehumidification or humidification. Also, if you're using an integrated system with reservoir type cladding, stucco, brick, masonry, it's probably a good idea to put another layer of something, be it house wrap, felt paper. I really like felt paper because it's got a throttle in it when it comes to permeability. But it's a good idea. This is equivalent to 1 layer of grade D. And the Bricklayers Association recommend, it's not by code, but they recommend 2 layers of grade D. So what we did back in the day with felt papers, we half lapped it so that you would get 2 layers that way. And so we're kind of losing that when this is sold as a replacement for house wrap, and you don't need to put any on there. Think about what it is that you're putting up for a cladding, because you may still want to. Now, are you saying, well, now I've just put in 2 WRBs. What you've done is you've created a great air barrier by putting up this, and then you've created a good water barrier because you are going to get water to it. At the end of the day, these are wood products. This on top of it is still a wood product, and it will get wet, and if it stays wet, it will allow it to soak through into the wood.
Let me ask one last question. We're coming in on the end. We won't nerd out too much longer, but when this is on the roof, and I didn't, we'll leave this to the side because I did not know that it was approved for roofs, and I don't know anything about that. So I want to look more into that. But when this is on a roof, we used a standing seam metal roof on ours, and I thought, okay, great, I don't have to worry about water getting back behind that. But if you use shingles are pretty, like, I like to assume that they're gonna leak at some point.
Yeah.
If you got a ton of nails through this thing, is this thing self-sealing against nails that are not overdriven like this one is right here?
Yeah, you know, this would be a nail that would be overdriven, say, in the installation of the sheathing to the rafters. Okay, and then you've got a bunch of nails from the shingles going on there. They're not really sealing around. Your best seal around that nail is the shingle itself. As it goes through the shingle is where you're getting that water sealing. So you've broken the plane of this, but in its service, it's going to be fine. Now, if you replace that roof, you're going to have to cover this up because of all the holes. It's not the same product that it was when you put it up new. So 25, 50 years, whatever, your roof is and you got to replace it, then you'll need to put a felt paper or some sort of underlayment on top of it.
What about something like a Grace Ice and Water Shield over the whole thing? That's something that people are starting to do now. Again, that analysis paralysis, like I just want to make sure there's no problems at all. Insurance policy.
I don't have a problem with that.
Okay.
I really don't. And an example, I did a studio down the road here, and it's built kind of like this barn. We took down old barns to build this thing, and that's what they wanted, this old barn look. We even took down old metal off a barn and put on that. This metal had holes all in it. So we had zip. We put the Grace Water Shield on top of that because I knew that roof was going to leak. So basically, in the way I think about it, when I'm building anything with these products is build it like this is it before I put anything on top of it. This is going to keep all the air out. This is going to keep the water out. This is going to do everything that I need. Now I'm going to put a facade in front of it.
Right.
Whatever it is, that's what I'm going to do.
It would then, if you're going to use something like Grace or some other fully adhered membrane on the top, especially something that's like butyl that's going to self-seal around nail holes, would this need to be zip or could this be just a 1/2-inch OSB or a 7/16 for that matter?
Yeah, it could be whatever you want to. The Grace is going to stick to this better than it does OSB.
Really?
Yeah.
Okay.
Rule of thumb in developing these products is all you really need is a surface that tape will stick to.
And that's what this and this did.
You create a surface that tape sticks to, you're 99% there. The other thing is you've blocked off all those voids. Now that we've overdriven the nail, you could see there's lots of voids in OSB that allow moisture to move through, and you've just blocked up that right there. So anytime you overdrive a nail, if it's going to get a lot of water, say it's behind brick, it will. Just imagine if you had that up on a wall and you had a brick tile right here and an overdriven nail right underneath it, and you had mud that came back all the way, because that'll be what happens.
Every time it rains outside there, I'll be constantly...
It'd be constantly wetting that right there.
Like a hamster feeding water bottle.
Yep.
I've never had hamster, I'm pretty sure that's how it works.
When the rain quits and the sun comes out and it hits that brick, it's driving that moisture in.
Well, thank you very much for ideating both of these products. Not every day that you get to talk to somebody who invented the things that we're using in the building industry all the time, so I'd like to shake your hand.
Yeah.
Awesome. You guys, as you have comments or questions, post them below. I'll see if I can drag Landus over to answer any of the comments or questions. But please do make sure that you like and subscribe as well. That always helps. Tune in next time.